Hello students, welcome to RD Chemistry. Let us see the first question. The first question is match the following. They are given the ligand and they given the type of the ligand. Now the first one, diethylene triamine. Let us write down ethylene diamine structure. Ethylene diamine, right? We write like this. Ethylene diamine. We write twice NH2, correct? Now it is diethylene. So let me write diethylene. This diethylene diamine, correct? Huh? Okay, then they mentioned triamine, one more nitrogen amine group H. Okay, so nitrogen contains lone pair, can be donated, and there are two more nitrogen atom can be donating the electron pair, and there are altogether three donor atom ligating atom. So it should be tridentate. So P, I can go for Roman number 3, right? Thiocyanate, thio, sulfur, cyanide is Cn minus. Okay. Sulfur can donate electron pair, or sometimes nitrogen can also donate the electron pair. These are ambidentate ligand, and here only one atom donates at a time. So it is a unidentate ligand. So thiocyanate is of Roman number 1. Ethylene diamine, okay, ethylene, CH2, diamine, NH2. So nitrogen contains lone pair of electron, therefore it should be, okay, didentate ligand. Therefore R, the Roman number is 2 here. For this Roman number is 2. Okay, and last one, EDTA. EDTA stands for ethylene diamine tetraacetato. Okay, and that is the hexadentate ligand, right? So the answer is option number 3. Clear? Question number 2. The complex is given. When treated with the silver nitrate, it gives a precipitate of. In all these cases, you can see chloride, bromide, iodide, bromide, iodide. Now, with this complex undergoes ionization, it gives Cr, En twice Cl and Br, and outside we have got counter ion iodide minus. This should be -1, this should be +1 in the solution. So therefore, only the counter ion I minus can react to the silver ion present in the silver nitrate to give silver iodide, the yellow precipitate. Whereas chlorido and bromido are ligands, they are not the counter ion, they cannot react with the silver nitrate. Okay, so therefore answer is option number 3, silver iodide yellow precipitate. Okay. Question number 3, match the following complex and isomerism dimension. See the first complex, cobalt and chromium. There are two coordination entities. Remember, when there are two coordination entities containing two different metals and different types of the ligand, it must be the coordination isomerism. Okay, so that is Roman number 3. Okay, see with the B complex now. In the B complex, there is a NO. It can be Br outside. It can be ionization isomerism. Ionization isomerism that not been mentioned here, but we have got here NO2 minus. Either nitrogen can donate the electron pair, okay, or oxygen can donate the electron pair. So this is the ambidentate ligand. If there is an ambidentate ligand, it can show linkage isomerism. Remember that. So B, Roman number 4. Okay, Roman number 4. If you see carefully, option number 3 would tell you 3 Roman number 2 Roman number 4 NB complex. Then you have got C and D. Okay, there is a En in the option number 3. There is a En ligand, didentate ligand. Whenever didentate ligand is there, now we are left with the only two options, either geometrical or optical. Okay, geometrical is possible for option number C here, C complex, because Cl there are two in number. We can write a cis and transfer Cl. Okay. In the case of D complex also, Cn is repeated 2 times. Cn can be cis to each other, Cn can be trans to each other. If there is a didentate ligand, we can expect the optical isomerism. Remember that. Okay. Therefore, complex number C should be Roman number 2, and you're left with the geometry isomerism for, okay, D option. That is Roman number 1. So the answer is option number 3. Correct? Okay. Question number 4. Match the complex the column 1 with the oxidation number in the column number 2. Let us see the option number A, that is first complex. Potassium 3. Okay. Plus let the cobalt be X. Plus 2 times oxalato. C2O4 means oxalato. Total charge is minus 2. Chlorido minus 1 charge twice. So total is equal to 0. So X is equal to, here we have got minus 4, minus 2, the minus 6 and plus 3. So plus 3 state. Okay. So this is a Roman number 3. Okay. So go on finding out. Platinum we have got, let it be X in the option of B complex. Then C2H4 is a ethene neutral. So 0 charge. Chloridos are 3 number. Total charge is minus 1. So we can expect X is equal to plus 2. So that is a Roman number 4. Okay, right? So 3 and 4. 3 and 4 comes again in the option number 3. Right. We'll go for the option number C, that is the complex C. This is unusual complex actually. Right. So here iron, let it be X, plus 5 into aqua is 0. Here we have to consider the night NO plus is there. NO, nitrosyl neutral ligand, but in this complex, nitrosyl, nitronium ion, nitrosonium ion, NO plus 1 becomes. So plus 1 state. And sulfate, total charge is minus 2, total is equal to 0. So X is equal to plus 1 we can have. So unusual iron 1 state, remember that one. That is the option number 1. Okay. Then last one remain nickel complex. Carbonyl is a neutral ligand. So therefore X plus 0 is equal to 0. So it is 0. Okay. Right. Complex number C, iron is plus 1 state, that is the option number 2. And D, your nickel 0 state, that is the option number 1. Okay. So the answer is option number 3. Is that okay? Fine. Question number 5. Which of the following ligand forms chelate? Chelate means those ligand, that is a didentate ligand or the polydentate ligand which can form ring-like structure. Acetate CH3, COO minus, oxalato CO minus and CO minus, cyanide CN minus, ammonia amine. Okay. Didentate ligand or polydentate ligand have the capacity to form ring-like structures which are more stable complexes. So oxalate is the answer. Question number 6. Copper sulfate CSO4 dissolves in ammonia NH3 because it can form the complex Cu NH3 altogether 4 times, coordination number is 4, and outside we can have SO4. Okay, it is SO4. Initially copper sulfate hydrous one is the blue color, or pure anhydrous is the colorless, and it forms here a deep blue color solution. Okay, answer is option number 2. Question number 7. Which of the following complex ion exhibit linkage asymmetry? Remember, there must be at least one ambidentate ligand. Fine, ambidentate ligand. Amine is a not ambidentate. Ethylene diamine, chlorido not ambidentate. Nitrito is a ambidentate ligand. Right? So therefore, answer is option number 2. Question number 8. Geometry isomerism in coordination compound is exhibited by. Remember, tetrahedral complexes do not show cis and trans isomerism, because if you change the ligands, the bond angle is always 109.5 degrees. The relative positions are the same. Therefore, remember, tetrahedral cannot show cis trans, remaining square planar, and the tetraoctahedral can show the cis trans isomerism. Therefore, answer is option number 2. Right? Question number 9. Which of the following octahedral complexes does not show geometric isomerism? To show geometrical isomerism, compound must not contain planar symmetry. There should not be planar symmetry in the molecule. No planar symmetry. Remember that. Okay. If there is a didentate ligand like this, okay, they can show geometrical isomerism. They show optical isomerism. So we are left with the first option and the fourth option. If we see the fourth option, and if we arrange A, 5 and B in different positions, we can have definitely the planar symmetry. There is a planar symmetry in the molecule. Whereas in case of option number 1, we can avoid the planar symmetry by arranging the ligands. Okay, so it can exhibit a geometric isomerism. Remember, option number 1 can exhibit geometric isomerism. Where option number 4, whatever the arrangement of the ligand, there is always a planar symmetry. So the answer is option number 4 here. Okay. Question number 10. Complex the composition A2, B2 and outside X2. Found there are no geometrical isomerism. And A and B are monodentate. See here, the coordination number of this complex is equal to 4. Either it is a square planar or tetrahedral, cannot be octahedral or linear. If the coordination number is 4, then it can be either square planar or tetrahedral. Remember, tetrahedrals do not show the geometrical isomerism, because when you interchange the ligand, their bond angle always remain the same. Their relative positions are always same. Therefore, the answer is, it should not show the geometric isomerism. The answer should be option number 3. Third one is the answer. Thank you for watching. Have a nice day.